This DC load flow. I started to record the meeting first. So when we are talking about this DC load flow, I'll maximize this. Okay, the DC load flow. Na? On that, if you can see in the DC load flow, there is a problem. In your question paper also, they have asked the problem. Okay.
Yes, sir.
So what I yesterday I have told you forward and backward sweep, right?
Right, sir.
There's a question also that has been asked in the question paper. But the data there is different. Okay.
Yes, sir.
So I'll send you the link. Okay. Send you the link after the, sorry, send you the PDF. Okay.
Yes,
You
sir.
you try to solve the question paper problem. Okay.
Okay, sir.
You try to solve the question paper because there is a different data asked.
Yes,
Yes,
sir. Yes, sir.
and send me the solution. I'll see whether you have understood or not. If you will be able to,
Okay.
if you will be able to solve that forward and backward sweep, then you will be able to solve in the examination also. Okay.
Got
Now,
it, sir.
now in a DC load flow analysis, basically this DC load flow analysis, na, in this, when we were doing Gauss Seidel iterations and we were doing the normal power flow analysis, we saw that we calculated all the values. We calculated real power, reactive power, current, everything we calculated in that. But in this DC load flow, na, only the real power is calculated. So it is basically used for monitoring purposes only. So it is not used for the calculation of every value will not be calculated. So it is used for monitoring purpose, for monitoring purpose only. First thing will be okay. First you understand what is this, and then it only calculates DC load flow will calculate only real power. Okay, only real power. So here in the DC load flow, to do this we have some assumptions. So these assumptions we have to take before doing the DC load flow. Unlike the AC load flow, the DC load, for that we have the number one assumption is that all resistance and shunts are neglected. Okay, so all resistances and shunts would mean a branch that is coming in parallel, and shunts would mean a branch that is like a, suppose you are having an X11 branch or X22 branch. Okay, these are neglected. When I will be solving the problem, you will understand these are neglected. That would mean, for example, a transmission line we have, a transmission line impedance yesterday we saw was written as R plus JXL, right? So
Yes, sir.
if I neglect this resistance, this is neglected. Now my new impedance value, now my this Z would become how much? Z would become XL only. Z will become
Yes, sir. Yeah.
XL. So this thing you have to remember, all the resistances are neglected. Okay. Now the transformer, basically transformer steps up and steps down the voltage. Okay. Steps are up and steps down. Transformer main purpose is to do, okay, change of voltage. Transformer does change of voltage or current, that without change in frequency. Okay, with constant frequency, basically constant frequency. So here one more assumption that is there: the transformer tap are assumed to be at a nominal setting. Transformer transformer
Taps.
tap, that is the ratio. Okay, tapping. See, suppose
Yes, sir.
you have a transformer. You have a step up transform. This is your transformer. Okay, this side is your step down side. You feed 120, and this is 1:2 transformer. So this is, suppose you don't know the other value, so you'll write X divided by 120 x divided by, sorry, 120 divided by x is equal
Yes,
to
sir.
1 is to
Equals to
2.
1 by 2 and
So x would be equal to 240.
40.
Here you have the constant ratio 1 is to 1. So these taps are transformer taps are assumed assumed to be at nominal setting nominal setting of 1 per unit. This is one thing. Then all the bus voltages, like in the DC and AC sweep, primarily first the bus voltage was calculated, then the current was calculated, then the drop was calculated. Once that drop was calculated in the second iteration, that drop
To get
resulting
the,
in
yeah,
that drop which it caused a different voltage, that voltage was substituted. Okay,
correct, correct, correct.
so now here all bus voltages are assumed at all bus voltages are assumed to be assumed to be 1 per unit. This is, and then the angle difference between, see you have a transmission line here. Okay, this is a transmission line and you have a voltage phase of 1. This is your line 1. This is the second line. This is here V1 at an angle of 0 degree, V2 at an angle of 0 degree. So according to this, what the first thing what will happen is that this V1 at an angle of 0 degree would be equal to V2 at an angle of 0 degree, and this would be equal to 1 at an angle of 0 degree, because we assume it to be 1 per unit. Okay, first thing. Why? Because of assumption number third assumption, because of this
Yes.
assumption number third. Okay, then the second thing is that the angle here, for example, this is phi 1, this is phi j. Okay, now what is happening here? Now if you look angle difference between voltage phasors, that is the angle difference between between voltage phasors is very small. Phasors is very small. Okay, this is one point. Now the final point is that it does not give the accurate value, but it gives you the approximate value of real power. It by that it will not be, it means you will only be able to calculate the real power. It gives only approximate, because you are neglecting so many things. Approximate value, because you're neglecting the loss that would be due to R, because there would be definitely I square R loss in the line. And I told you I square R will call loss, but there is no loss when you are calculating IXL. Why? Because the power factor in the IXL case would be VI cos 90 degree. That would be equal to 0. Okay. So it gives only approximate value of real power. So these 5 points are the valid points here. By the time, let me save this PDF. Okay. Now you have this formula for if there is a line here, let this line be I and this line be J instead of I. Okay, or I can write P12 also if you like it, but Pij will sound more good. Pij. So what is the normal formula for the power in a transmission line? What we when we studied for the this thing, even other day we had calculated that current transformer, that stamping angle error. So what was that formula for power? Power
E
formula
to
is
I, the voltage difference into
no 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 no
into the current of the
no no no, the power difference was CVI into VJ, right, divided by X sine delta, right? Forgot when I taught you the load flow analysis. We have written this formula, right?
Yes, sir. Yes, sir.
If you go back to your load flow analysis, you will see this formula is there. Kindly start revising because examination. When is your exam of smart grid?
Sir, they had scheduled it for 4th, but there's no definite date.
Huh?
So they had scheduled it for 4th, but it's not confirmed yet.
It's not confirmed. But if it is confirmed or not confirmed, but if it's supposed to be at 4, no, the days are very less.
Yes, sir.
How many subjects apart from smart grid we are having in the 8th semester?
Just this, sir.
Just this. So you have to do well in this. You have only one subject to read. So kindly
Yes,
go
sir.
through it. Okay. On what topic you are doing project?
So the project is done, sir. It's finished. It was a battery monitoring system for electric vehicles.
Battery?
Battery monitoring system for electric
Oh,
vehicles.
BMS. I have most of my research is on that. If you
Oh,
type my name on Google, you will get S Zahid Navidar. You type my name, you will see all my papers there. This is my name.
oh,
You can Google my name. I have many papers in very good SCI index journals. I have almost 17 papers in IEEE. So
it,
most of my research is you can if you type my name at IEEE Explore, all my papers will get, and most of the work is on that battery monitoring only. Anyways, okay. Now you tell me. You have noted it down. Kindly note it
yes,
down.
sir.
Then we'll move to the
Yeah,
next slide. Hmm?
got it.
Hmm. I think you are not yet putting effort. After the class is over, you please put little bit effort because in the class you are very sound. As a student, I saw your pickup is good. But as far as effort is concerned, I don't think you are putting effort.
I
Uh,
see.
yeah, am I correct? Don't feel bad.
Sir, no, no, sir, no, no, of course, not, sir.
No, no, you are like after that, after the class, you study 2 3 hours, no? Then you will
Yes, sir.
be able to remember the things. There
Right.
is one technique I'll tell you. Once my class finishes, immediately after 10 minutes, you revise it, whatever I have taught you. Okay. And whatever doubts you have, you write down. Doubt tomorrow I'll ask sir this, and this. Okay. Then after 1 hour also you revise. 1 hour. Then after the same thing you revise after 24 hours and after 1 week and after 1 month. Then for your entire life you will not forget. No need of revision. This is scientifically proven. This is a scientific fact. Throughout until your deathbed, you will not forget this. 10 minutes, 1 hour, 24 hour, 1 week, and 1 month. So you need one revision, revision second, revision third, revision four, and revision five. Five revision, five revisions, and it will remain with you forever.
Right, sir.
Uh, can I move to the next slide now?
Yes, yes, sir.
Hmm?
Yes, sir.
Yeah,
Yes, sir.
yeah. So we now we had written the formula for the power basically was equal to this is my transmission line 1 and this is my xij. This is my jxij. Okay, and let this be my I and the value of voltage here Vi. Let this be 1 at an angle of delta I, and here Vj, let this be equal to 1 at an angle of delta J. And these are the lines. This is line A and line J. So
So, but
basically,
for the so,
yeah,
but for the impedance, we don't consider the J part, right? It's just Xij.
no, we are in the impedance. We are normally the impedance yesterday when I've shown you, we wrote like this R plus
Yeah, R
ZXIJ.
plus J of XL. Yeah, correct.
So you saw
Yeah,
right
exactly.
yesterday it was something like this 0.3 plus
Yes, a 0.3 plus J
4.6
of zero point 0.6. Yeah, yeah, correct, correct.
ohms per mile, right? But
Yeah,
in the DC load flow, this part is not there. R part is not there. Only this part is there. Okay.
yeah. Okay.
This is the assumption. Because of the assumption that we don't consider any R part. No R part will be
Alright.
considered. Okay, now the thing is that now your Pij value would be equal to 1 by Xij into V1, V2. into how much? Into sine of what is the angular difference? Now it will be the sine,
So
the theta here
x
would be the
delta I. So yeah, theta I minus
delta I minus delta J.
delta I.
This theta would become equal to delta I minus
Minus delta
delta J.
J.
Do you like the red or the black color? Which color you prefer? When
The
I'm
red. So
red is more good, na? Yeah, that's why I
yes,
moved.
sir. Yes, sir.
Yeah, red is more visible. So now you tell me what is the value. Black I will use to just to differentiate. Okay, what is the value so
Yes,
that
sir.
you can take it down. So now what is the value of V1? V1 is 1 at an angle of 0 degree, right? Okay.
Uh,
What is V2? V2 is also 1 at an angle of 0 degrees. So 1 at an angle of 0 degrees into 1 at an angle of 0 degrees will give you 1 only, right?
uh,
This will give you 1. Okay.
yeah,
Because see, at an angle of 1 at an angle of 0 degree would mean cos 0 plus j
yeah.
sine 0. J sine 0,
Uh,
sine 0 is 0 only.
that is zero
Cos
only.
0 is 1. So the total
Yeah,
value here would be 1 only, right?
correct,
So
correct.
V1 into V2 will be 1
Yeah,
divided by xij into sine del I minus del j. So your formula becomes like this. Pij would be equal to the modified formula. This is the modified formula for the DC load flow. This is the modified formula. Modified
formula.
formula for
Oh,
DC.
so it's completely based on the
Formula
angles of the this thing.
for DC load flow. Yeah, now it's completely based on the angles. See, the same thing we have used when we have calculated that stamping angle error, stamping and phase angle error. We calculated one problem, we had done phase angle error. So it was done, okay, on the basis of the same formula. This same formula I had applied. Unfortunately, you have not gone through it. Okay.
So, but then, so in this case, the reason why D1 and D2 is one is because one angle of delta I and one angle delta J.
No, not because that, because you see the assumption, we have taken an assumption. All bus voltages are assumed to be 1 per unit. Because of that, this is 1 at an angle 0 degree, 1 at an angle 0 degree. Because of this assumption, there is an assumption for DC load flow. All bus voltages are assumed to be 1 per unit. These are the conditions for DC load flow. This is how we do. This is the technique, conditions for DC load flow. Okay. Because of this only we are doing. Got it?
Yes, about it.
Yeah. Any doubt you have, you tell me. No issue. I'm there to solve. Modified formula for
Yeah,
DC load. Now, see, we all know if the power is going into the bus. So this is power injection, right?
yes,
So
right.
power injection, I have told you in the load flow analysis, it's taken as positive,
Correct.
right? If
Yeah,
power is moving away from the bus, that means it is getting absorbed. Okay. So absorbed, like in a PQ bus, power, because PQ bus is a load bus. In
correct.
the load bus, what will happen? Power will get absorbed. Whenever there is power absorption, it means it is a negative. Whenever there is power injection, it is positive, right? I can explain you
Yeah,
this. See,
yes, sir.
you have a voltage source. Okay, you have a resistance. Okay, your connection is like this. So from the voltage source, whatever the current is moving like this.
Power is yeah,
Yeah. So here voltage source is supplying power, right? It is supplying power.
correct.
So
Yeah,
supplying power. So this direction of supplying power is considered as positive, because see here this is minus means lower potential, plus
yeah,
means
yeah.
higher potential. So the current is moving in the rise of potential. So this direction, if you can look, this is the rise of potential, right? Rise of potential. So it is moving the direction of rise of potential. So this basically means now here across the resistor, you again see this is plus, this is minus. So now in case of the resistor, you will see this is plus, this is minus, and the current is moving plus to minus. So it is again what is happening here? There is a drop in potential. drop in potential, right? There is a potential drop in
Yes, sir.
potential. So this drop in potential is taken as negative. Similarly, here injection is like supply, and when it is moving away from the bus, it is absorption. Yesterday we had done DC sweep, AC sweep. In that also you see here we had
Yes, sir.
connected like this. If the three buses were there, then one bus was flowing like here, another was flowing like here. So the primary, if this was V1, this was V2. So this was your Z12, this was your, if this is V3, this was your S2 and S3, and this was your Z23. So here you always remember your V2 was always lesser than V1. V2 will be always lesser than V1. Similarly, your V3 would be always, I have written greater than, it should be lesser than V1. Or in other terms, I can write V1 is always greater than V2. Similarly, V2 will be always greater than V3. Why is that case? Can you tell me?
So because the power is flowing, so
No,
all
no,
of
no, no, no,
it's
no,
flowing
no,
from V1 to V2.
because this is the supply here, right? V1 is the supply. From the main supply, this is the drop. If this I12 is the current, then V1 you can write V1 would be equal to V2 minus I12 Z12.
Z1 to
Okay, you can, no no sorry यार उल्टा लिख दिया हमने. V2 is equal to V1 because V1 is the supply,
yes, sir.
right? From, or else we can write V1 is equal to
V1 is equal to
V2
V2 plus I1 to
I12 Z12. Okay, because your supply would be always larger than the receiving end, right? I have shown you this.
yeah.
Yeah. Now this is just for the explanation purpose. I'm going little slow. Why? Because I think if I try to cover the syllabus only, na, matlab your little bit concept I felt are a little bit here and there. Like why is it so? Like they don't teach like the basics and all in VIT, like, or you have missed many classes like basic. What about the basics like basic electrical networks and this power system?
No,
These
sir.
things,
Classes are taken, but sir, it's been a while. I've been disconnected from college for a while. That's the issue.
huh?
I last time I went to college was almost a year back.
Reason why you have discontinued? Because of
No,
your
no,
health?
no, sir. I didn't discontinue. I had my classes online, obviously during COVID, and then after that, my third
Ah,
year,
ah,
I
yeah,
had to take a break because of I was undergoing chemo, sir.
yeah, yeah. Oh, you take down this. You were undergoing?
Chemo, sir, chemotherapy.
Oh my God, you have cancer, huh? Chemo?
Sir, had sir.
Oh my God. In such a, how old are you?
Sir, 21, sir.
Your father is a medical doctor, right?
Yes, sir.
Like you smoke and all something, or like how you got
No,
it?
no, sir.
Hmm?
It was a tumor, sir, on the back.
Oh, okay, okay. No, no. Normally, it happens to your good people only. No? Okay, no issue. So, can I move to the next slide?
One second, sir, one second.
Yeah.
Yes, sir.
Yeah, I'll be moving to the next slide. Now, you basically, if you look at the real power injection at any bus would be given as, see, this value Pij, what happened? Hello?
Yes, sir.
Yeah, 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 okay. Okay, okay, yeah, yeah. It got disconnected by this pen. So your Pi,
Oh,
yeah, if you have to write your Pij value, you can write this as J is equal to 1. Okay, summation of all the buses basically Pij. So this would be equal to, if you have to do this would be equal to the, in terms of your angular difference, So if you keep the this values of the angle, so you can write this as you basically you saw this Pij was equal to 1 Xij into sine of del I
delta I
minus
minus
del J.
del J
So here this Pij would be equal to for n bus. Okay, if you take the maximum value of this, if you take this del I minus del J to be equal to
equal to 1.
like 1. In that scenario, it would be equal to n bus would be equal to j is equal to 1, j not equal to I. Okay, this I
Then I
don't
equal to 1.
uh, uh where it went.
So I equal to 1 and J equal to 1.
No, 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 no. J not equal to because you are taking from this bus one because starting point is your I
Yeah.
and I to J. Okay, so your J should be equal to 1 and J should not be equal to your I value, right? J, see,
Okay.
I is the start point.
Correct. Correct.
Okay, then the terminating point is J. So which
Yeah. Yeah.
J can be, see, this is I and this J equal to 1. Suppose J equal to 2, J equal to 3. So got it? Xij del I minus it can be given as J equal to 1, J not equal to I again, n bus 1 by Xij delta J. So now you can do one thing, you remember one thing. See, this 1 by Xj term, what you saw now, 1 by Xij term, it is basically the susceptance. Susceptance. It is the inverse of reactance is called as susceptance. Do you know inverse
Yeah.
of inductive reactance is called as susceptance? Yeah, yeah, which is given as Bx. You can write as Bx, okay, or
Yes.
okay, you can Bx Ij. This can be written in form of Bx Ij. So you from this you got one thing that your Bx Ij is nothing but that is equal to 1 by Xij. One thing you got here, right? Now,
Yeah.
if you carefully look at this formula, if you carefully look at the earlier formula that I had written, wherein I had written P is equal to 1 by Xij del I minus del J, right? Del I minus del J. This term Bxij can be written in this format, right? In this format. So instead of 1 by Xij, what I can write? P is equal to, instead of 1 by Xij, what I can write? P is equal
Yeah.
to
X
Bx, very good.
Bxij
Bx ij into delta
del
I
I minus
minus
del
delta
J.
j. So this is the primarily this is the formula that you will be using for this load flow analysis.
Okay.
In similar terminologies, you can write this formula in a matrix form. P is equal to Bx. In your notes, I did not see this, but I saw a problem. I saw a problem in your question paper they are asking. Okay, so I thought the see whatever the easier part first, you should do the tougher part so that you
Yes,
will
sir.
be able, because nearer to the exam, if I do this, then you will not be able to. So you can practice it.
Yes,
Okay,
sir. Yes, sir.
you can practice it. You will get a hang of it. That's why you are feeling this very difficult, na? This
Yes, sir.
because in the very beginning you told me, sir, from where the current is coming, where the current is leaving. Okay,
Yes, sir.
that's why I thought here the theoretical part and some easier portions we can do later. But
Okay, sir.
let's start with this. Then if you are comfortable with this, that we can do very easily. Okay.
Okay.
Now the same thing, if you want to express, you can also write this as this is the formula, this is the formula we will require. We can also write it in this form Bx inverse. Okay, it's a matrix. Inverse is equal inverse into P is equal to delta, right? Remember this. Okay, this is
Okay.
only now on the basis of this formula which I have arrived. what I can do is, see, this bx and this p can be written in this matrix form. Okay. So when I write like this is a matrix form. Suppose
Yes, sir.
we have a bus, okay, where power is entering, power is leaving. Okay. This we have like two, three buses that are connected where power is entering, power is leaving. So we can express the power here, this p value as P1, P2, and how many number of buses we have? Up to Pn buses. First, you note
Yeah.
down this, then I will show that in the next slide.
Yes,
No,
sir. I wrote down this.
you have not. Can I move to the next slide? I'll save this
Yeah,
slide.
yeah.
I'll save this slide. Can I move to the next? Okay, yeah. So,
Yes.
what I'm telling, yeah, yeah, what I'm telling is we can do like we can write this in terms of P1, P2 up to Pn minus 1 buses. Sorry, Pn minus 1, no, Pn buses. Pn bus up to the last bus, Pn bus. Okay, that was Pn dash buses. Okay, then this
Yes, sir.
bx would be the matrix part of the bus value. Suppose you are having these different buses you are having, where bx can be expressed as b11, b12. Okay, if you have two buses, then it would be only b11, b12, b21, and b22, right? If you have suppose two buses, here there's one, then it can be expressed as first value would be, okay, like I'll, if you have, for sorry, if you have three buses, you can express this like this. I'll explain you in a problem, it would be in a much better manner.
Yes, sir.
So in problem it will get clear. Here if I explain you, then I have to explain another 1 hour. So that much,
No, 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 sir. I understood this.
then del 1, del 2, and this is del n bus. Okay, like this we'll do. Now note down this. Okay, now we will do
Yeah,
a, now we will do a formula. Write
yeah.
down this problem. A similar problem has appeared in your
Yes, sir.
question paper. Okay,
Yes, sir.
calculate calculate the DC load flow. Calculate the DC load flow. The problem is like this. This is 65 megawatts. This is getting injected into the bus. Okay, and this is bus number line number one. And okay, here, and this line is getting connected. This line is getting connected to bus two here. This is your line number two, and from here, from this bus, now you see this bus is, this power is going out. This power is going in. So
Yeah.
if I have to consider P1 in this case, P1 would be plus 65 megawatt. And if I have to consider P2 in this case, P2 would be, this is showing 100 megawatts. P2 would be equal to minus of 100 megawatts. Why it would be equal to minus of 100 megawatts?
Because it's going outside.
Because it's going leaving and it is acting as a load. Acting as load. Because of that, it is going. Okay, then this is my line number one. The value of line number one. So he is giving me the value in terms of x, x12. X12 is equal to zero point 0.2, right? Then I have another bus that is going down here. Okay, and this is the line number three. Okay, wherein I have my line number, yeah. So yeah, x12, and this is my bus number. So this is my here. So this was my line one, line three, and this is my line two here. Line for the line two, because the line is represented by the transmission. Line is represented always. Line would be represented by this value, x value. So wherever you are finding the x value, see here I will draw also for you. So it will become easier. So this is line one, this is the x value here. Okay. For line 3, I'll draw the X value. Line 3, here is the line 3. Okay, normally in the paper, it won't be like this. Just to
Yes, sir.
explain you, it will be straightforward and they will give the value of
Got it, sir.
X value. X value would be equal to, here X value is 0.4. Okay, and at line 2, the X value at line 2, X value at line 2 is equal to 0.25. So this is zero point 0.2, zero point 0.4, 0.25. This is your one at an angle del 1, one at an angle of del 2. So if you look at this line and then you have one more line that is connected going here at line 3, again your power is going out. Okay, that is 35 megawatt. So this line, one of the line, you always have to take the reference line. So let's take this as a reference line and make it as a slack bus. So, okay. Now, once you have done this, now you have to remember one thing. The accountability due to the real power flow due to the slack bus. If we have made
Right.
that as a slack bus, in the slack bus, we have only voltage, magnitude, and angle. Although it is showing that 35 megawatt power, but that will not have an effect on the power flow analysis. And he says, consider consider base MVA to be equal to 100. Okay, base MVA is 100. Now you see this is in 65 megawatts. So you have this line has some value. So you have to convert everything into per unit. Now, in order to convert everything into
So one second, one second, one second. So which line has value you mean? So
huh?
line one, line two, line three.
This one, line three.
Okay, line four.
This you don't have to take into account. The line
Yeah.
3, yeah, line 3 you don't have to take into account. Line 3 you should not take into account. So now next class started, huh?
No, no, not yet, sir. Sir, but that is not line three, right? Line three, in fact, is the one three and two three is connected to the bus. The
No,
line that you're talking
no,
about
no,
is the one
no,
connected
no, no,
outside.
no, no, no. This, see, what we are, see, this is the power that, this is not line 3. This is the power connected to the line 3. See, like when we were drawing like this, so this is the power, like we were
Yeah.
calculating, right? We're
Okay, okay,
calculating.
okay.
So this was
Yeah,
S2,
yeah.
this was S3. On similar grounds here, this is injection. This is like
Okay,
that.
so
This will
basically
be rise
S3
to
is zero.
S3. It will show some value, but you have in calculation, you have to avoid. Okay, you have to make that as a slack bus. Okay,
Okay,
this is an assumption there.
okay.
Wait,
So,
I'll
sir,
see.
every single time we're going to consider that because
No, every single time you have to, every single time whenever your any problem will come na, at line 3, you have to assume it to, because see the because see you have only phase angle difference between line 1 and line 2. Your this formula, okay, if or normally it would be a
okay,
3 bus system. So one of the buses you have to take, one of the buses you have to take as slack, and mostly you have to take the line third as slack. Line third you will be
sir, once again, sir, there's less than a minute left. Can you save this in the paper?
yeah, line 3 you have to take always the slack bus.
Yeah,
So
I got it.
okay, now the thing is that the number one thing is what is the this if you look at the B11 matrix, B12 matrix, B21, B22, see P1 and P2 we can calculate. How we can calculate? P1 is the